For section 8.6, we're going to look at solving equations with radicals in them. So there are 4 steps to solving an equation with radicals. The first thing you want to do is isolate the radical, get it by itself, add and subtract anything over the equal sign that you can, multiply, divide anything that you can, get that radical by itself. Then you're going to apply something called the power rule, which I'm going to show you what it is in a minute, but basically it will eliminate the radical. You're going to solve like normal, and you're going to check for extraneous solutions. What is an extraneous solution? An extraneous solution is a solution that, when plugged back in, doesn't work out correctly. Let's take a look at this one first. We've got the square root of 3x plus 4 equals 8. You'll notice that the radical is already isolated on the left side. There's nothing added or subtracted or multiplied out that I need to get rid of. It's isolated already. So we skip to step 2, which says apply the power rule. And the power rule says, how do you get rid of a square root? You square it. Now if I square the left side, I have to square the right side. And what that's going to do is it's going to cancel that, just giving me a 3x plus 4, no radical sign. And 8 squared is obviously 64. Then you're going to minus over that 4, divide by 3, and you're going to get a 20. Now we actually need to check that 20 and make sure that it's not extraneous for whatever reason. And the way that we do that is we go back into the original problem, and instead of 3 times x, we now know what x is. It's 20, and you check it. So 3 times 20 is 60, 60 plus 4 is 64, and yes, the square root of 64 is 8. Therefore, x equals 20, and that is our solution. Let's go ahead and look at this, our second problem. Now, in this second problem, this radical is not isolated. There's a positive 3 that we need to move. So my very first step in this case is going to be to minus that positive 3 over to the other side, and then I'm going to apply the power rule. Now the power rule says if I square this side, it'll cancel the square root. I'm going to square this side. Now remember, we're squaring the whole thing, including the negative, so that's going to give us a positive 9, negative 3 times negative 3. We're going to add the 1 over, get a 10, divide by 5, we're going to get x is 2. I need to check this and make sure that it's not extraneous. So I'm going to go back into the original problem, and instead of 5 times x, I'm going to do 5 times 2, plus 3 equals 0. 5 times 2 is 10, 10 minus 1 is 9. So I have the square root of 9 plus 3 equals 0. Square root of 9 is 3 plus 3 equals 0. I already know that's not going to work, which means 2 happens to be an extraneous solution. Since 2 is an extraneous solution and we don't have another one to lean on, the answer to this is no solution. Now let's take a look at a little bit more complicated problem. So we've got a quantity on the left side and we have a quantity on the right side. You're going to follow the same rules. There's just going to be a little added work to this problem due to the fact that it's a quantity on the right side. So you're going to want to isolate the radical first. Well, guess what? The radical is already isolated, so we're ready to skip to the step where we apply the power rule and we square both sides. Now remember, just like I said with that negative 3, we're squaring the entire right side. So in other words, we're squaring the whole quantity x plus 2. So what's going to happen on the left side is the square root symbol is going to go away, giving us 4 plus x. But what happens here on the right side is we've got x plus 2 squared. And if we remember correctly, x plus 2 squared is x plus 2 times x plus 2. Well, x plus 2 times x plus 2, we have to actually FOIL that out and distribute it, giving us x squared plus 4x plus 4 once I multiply all my pieces out and put my like terms together. Now I need to solve for x, and I've got an x squared. And if you guys remember from your Algebra 2 that when you are solving for x and you have an x squared, you have to set it equal to 0 and factor. In other words, we need to add this x over, and we need to minus this 4 over, and actually set this equal to 0. 4x plus x is 5x, positive 4 and negative 4 cancels. I'm left with x squared plus 5x. If I would ask you to factor that, the first thing you would look for is a GCF, giving you x and x minus 5, x plus 5. Now you're going to take each of those separate pieces and you're going to set them equal to 0 by themselves, giving you 2 possible solutions of 0 and negative 5. Now what I'm going to do is I'm going to take that 0 and that negative 5 and I'm going to switch slides and we're going to check for extraneous solutions. So on this particular slide, like I told you before, I'm going to go ahead and check my extraneous solutions. So the first one I'm going to check is that 0. So instead of 4 minus x and instead of x plus 2, I'm going to go ahead and plug in that 0. So that gets me square root of 4 equals 2, and that one works. So we know that 0 is going to be one of our possible solutions. I'm going to go ahead and plug in the negative 5. So 4 minus a negative 5 gives me 4 plus 5, and then negative 5 plus 2. I get 4 plus 5, which is square root of 9. Square root of 9 equals negative 2. Let me go back and fix that. Equals negative 3. Square root of 9 is positive 3. It does not equal a negative 3. Remember, when we do square root, we take absolute value, so it does not equal negative 3. Making negative 5 an extraneous solution, making 0 our only possible answer in this case.